Welcome to How to Pass the Geometry Common Core Regents. My name is Guy Houtman and I'll be introducing myself a little bit more formally in just a few minutes. But just to make sure you're in the right place, number one, you are worried that you might fail the Geometry Common Core Regents. Sam on Twitter said, if I don't pass the Geometry Regents in June, I hope I pass it in August because there's no way I'm not graduating because of shapes and lines. Number two, you don't understand proofs, coordinate geometry, trig, triangles, circles, you name it. Natalie said, my geometry regions is in 15 minutes. Can someone please teach me how to do a proof? If that sounds like you, you're in the right place. And number three, in general, you struggle with multiple choice and short answer questions. All right, well, I'm going to be able to help you do that. And if you stay until the end, you will learn how to answer the easiest and most commonly asked concepts on the Geometry Common Core Regents. Number two, you'll also learn how to handle multiple choice and short answer questions. And number three, you'll learn how to get a guaranteed 65 plus on the Geometry Common Core Regents. This person on Twitter said, I'm failing the Geometry Regents tomorrow. Anyone know how to hack and can get me the answers? Well, I won't be able to get you the answers, but I will definitely show you some tips, strategies, and techniques to get you to pass with a guaranteed 65 plus. All right, so that's me. My name is Guy Houtman, and I have been teaching for over 15 years. I'm a New York State licensed teacher that was in both public and private school settings. As a high school student myself, I attended Staten Island Tech, and I graduated from SUNY Binghamton in New York. Okay, and I currently work at a New York City public high school on Staten Island. All right, and I'm also the creator of 50 Ways to Pass the Living Environment Regents, 100 Ways to Pass the Chemistry Regents, 70 Ways to Pass the Physics Regents, and 30 Ways to Pass the Algebra 1 Common Core Regents, and most recently, 40 Ways to Pass the Geometry Common Core Regents. Basically what I did was I went through 6 recent Geometry Common Core Regents exams to find the easiest and most commonly asked concepts and put that together into 40 ways to pass the Geometry Common Core Regents. So basically what I did here, and you should have received this study guide when you signed up. Now I also showed you how on the June 2017 Regents you could have earned 66 points, which could have translated into an 84. Would you be happy with an 84? And would you be happy with an 84 knowing that you probably could have earned that in just over an hour? The whole video series is an hour and 6 minutes. So round that up to 70 minutes. That's like an hour and 10 minutes, maybe even an hour and a half if you really wanted to get through it and take your time and get an 84. I mean, that's pretty crazy. All right, now so here's basically how this works. On the January 2017 Geometry Common Core Regents, to get a 65 you need 34 points, not 34 questions. Okay, 34 points. That means you could answer 17 multiple choice questions at 2 points apiece and pass with a 65. Same thing on the June 2017 Geometry Common Core Regents. We go right here. To get a 65, you need 34 points. Oh, sorry, I think I skipped one, right? June and August. August 2017, right here, 65, you needed 33 points. All right, what I did was I went through that exam, and notice here that goes down to 36. There's 36 questions. The first 24 are multiple choice, the rest are short answer questions. I also wrote down which way number from the 40 ways corresponded to each question, the concept, and how many points you would have gotten correct if you answered it correctly. And out of the 36 questions, 28 of them were covered by the 40 ways to pass the Geometry Common Core Regents, to the point where you could have earned 58 points, which translates into an 80. Again, would you be happy with an 80 on the Geometry Common Core Regents? I think so. Now, a little note here, just a little heads up. This was issued back in October of 2017. Starting in January 2018 on that test, they are removing one question. So instead of 36, there's 35 questions. They're actually getting rid of a 6-point question. I guess a lot of students weren't able to finish the test in time, but so now it's going to be out of 80. Now I don't know what the number of points will be to get a 65, but what I do know is that what I'm going to show you in this video series, it really doesn't matter because you will have the knowledge and confidence to pass no matter what. Okay, no matter what. So let's get started here. My goal for you is to easily and confidently pass the Geometry Common Core Regents in the shortest amount of time, even if you fail the exam many times before. So let's get started. Here's what I'm going to do. These are two questions, question 15 and question 17 from the June 2017 and August 2017 Geometry Common Core Regents that deal with segment partitions, which happens to be way number 21 on how to pass the Geometry Common Core Regents. Now what I'll do is, even though there's an explanation provided for you here, you might be able to figure out like that, or maybe even you already know how to do that. But if not, I think it's better. I'm going to show you the video for way number 21, and then what we'll do is we'll come back and I'll show you how to answer each of these questions individually. All right? So let's go to way number 21 on how to pass the Geometry Common Core Regents. Way number 21 on how to pass the Geometry Common Core Regents. Segment partition questions typically provide you with the coordinates for the endpoints of a line and then ask you to determine and state the coordinates for a point that falls on that line based on a given ratio. First, divide the change in x and the change in y by the number of partitions, which is nothing more than the sum of the ratio values. The values that you end up with represent the change in coordinates for each and every partition. The first number of the ratio tells you exactly at which partition you should stop and what the coordinates for the point will be, either graphically or mathematically. And yes, even if the ratio is not 2 to 3 or does not add up to 5, the method of finding the coordinates for a point on the line is the same. Divide the change in x and the change in y by the number of partitions, and the values that you end up with represent the change in coordinates for each and every partition. The first number of the ratio tells you exactly at which partition you should stop and what the coordinates for the point will be, either graphically or mathematically. Okay, that was way number 21 on how to pass the Geometry Common Core Regents. So now we're at June 2017, question number 15. So first, you want to get the sum of the ratio values. So anytime you see the 2 to 3 ratio, add them up. You get 5. That's what I did first. Then we want to get the change in x. So you're going to do 6 minus 4. That's what I did here. And you get 10. We're going to divide the 10 by the number of partitions, the number you got here, the sum of the ratios. You get 2. You're going to do the same thing for y. So I did 20 minus 5, which is 15. And we're going to divide that by the number of partitions, which was 5, and you get 3. So that now this becomes 2, 3, which is a set of coordinates. And the first number, okay, the first number of the ratios tells you at which partition to stop at for coordinates. Okay, so what that means is if the first set of coordinates in your data here is point R at -4, 5, we're going to add 2 to the x and add 3 to the y. So add 2 to the x, add 3 to the y, that's once. And then we're going to add 2 to the x and add 3 to the y, and that's twice, and that's where you stop, because the first number tells you how many times you need to do that. And that puts our answer at choice 2. And that's it. That's how you do segment partition. And then on the August 2017 Geometry Common Core Regents, you go straight to the ratio, you add them up, 3 to 5 is the sum of 8, all right, and then you do 16 minus 8, which is 24. 24 divided by 8 is 3. You do the same thing for the y, 6 minus 2, minus 2 is 8. Divide that by 8, you get 1. So 3, 1, that's how many places you're going to move the x. That's how many places you move the y. So we move 3 on the x, 1 on the y. We do it 3 on the x, 1 on the y, and we're going to do it a third time because the first number tells you when to stop. And the answer is choice 1, 1, 1. And that's it. That's how you use this way number 21 to answer segment partition questions correctly. Okay. Now next up on the proofs, right? A lot of you said you struggle with proofs. So here you have to prove that PQRS is a rhombus. That was on June 2017. Question 35. That's a 6-point question. Okay, so you're going to have to show some work there. And then on August 2017, it was a multiple choice question proving that ABCD is a rhombus. Now that deals with way number 28. There's could be a lot of confusion between rhombuses and squares, but you could read the explanation, or let me show you the video for way number 28 on how to pass the Geometry Common Core Regents, and then we'll come back and I'll show you how to answer each question individually. Way number 28 on how to pass the Geometry Common Core Regents. Rhombuses are a type of parallelogram whose consecutive sides are congruent, meaning that all sides are of equal lengths. They also have diagonals that bisect each other at right angles, but they are not congruent. This means that their slopes will be negative reciprocals of each other, but they won't be of equal lengths. Let's use the following question from the January 2017 Geometry Common Core Regents to illustrate this point. Parallelogram ABCD has coordinates 0, 7 for A and 2, 1 for C. Which statement would prove that ABCD is a rhombus? Since their diagonals bisect each other at right angles, their slopes will be negative reciprocals of each other. So if the slope of AC is negative 3 over 1, then the slope of BD is equal to 1/3. The negative reciprocal concept can also be used to determine the vertices of a square when only two pairs of coordinates are given. In the case of a square, consecutive sides are congruent just like a rhombus. And just like a rhombus, the diagonals of a square are perpendicular bisectors, except in a square, the diagonals are congruent. So if you know the slope of one diagonal in a square, the negative reciprocal will tell you the slope of the other diagonal, allowing you to determine and state the coordinates of vertices E and M. And just in case you need to prove that this is in fact a square, you can use the distance formula to show that all of the sides are congruent. And had they given you the other two coordinates for the rhombus, congruency can be shown here as well. Alright, that was way number 28 on how to pass the Geometry Common Core Regents. And so now we need to prove that PQRS is a rhombus. Well, in order to do that, it says here that rhombuses have consecutive sides that are congruent. So what you want to do is use this distance formula on all sides to show congruency. Okay, and so the way we do that is similar to what you did in segment partition where you got the change in x, but here you're going to square it, you do the change in y, and then you square it, and you take the square root of that, and that will get you one side. So when you do PQ, the length of that is the square root of 50. QR, the next segment, is square root of 50. RS, square root of 50. PS, square root of 50, and as long as you show that all sides of the rhombus are congruent, that's enough proof. That could get you points to prove that PQRS is a rhombus. So you want to use the distance formula on that. Now, I know some of you might argue, say, wait a minute, but squares also have consecutive sides that are congruent. So how do you know it's not a square? Well, you know what? This was a 6-point question. So just this work here alone, getting it right with all the work, gets you 3 points. For an additional 3 points, they also wanted you to prove that PQRS is not a square. Okay, now so we need to take that to the next level, and that means we need to look at the diagonals. See, the diagonals in a rhombus bisect each other at right angles, but are not congruent. Okay, in a square, they are perpendicular bisectors as well, but they are congruent. So that difference right there is how we're going to show that PQRS is not a square, which once again will involve the distance formula. Now we're going to do that for the diagonals. So we're going to do P and R and Q and S. So here is PR. The distance for that was the square root of 40. QS is square root of 60. And as long as you say that since diagonals are not congruent, rhombus PQRS is not a square. And that combined with the work shown before and the explanation, the correct answer, will get you 6 points, would have gotten you 6 points on the June 2017 Geometry Common Core Regents using way number 28. Okay, now August 2017, this is a 2-point multiple choice question. If ABCD is a parallelogram, which statement would prove that ABCD is a rhombus? Now, we can't prove that consecutive sides are congruent, but we can say that the diagonals bisect each other at right angles, which is going to be A to C and B to D, making choice 3 the answer. Okay, so that's basically the explanation I'm providing for you right here. All right, again, diagonals AC and BD will be perpendicular to each other, but not congruent, making the correct answer choice 3. See, AC and BD is congruent. That would be true for a square, but not for a rhombus. Okay, so that's 2 points on the August 2017 Geometry Common Core Regents. On the same test was another multiple choice question that could have been answered correctly using the information from way number 28. This time they say the vertices of a square, RSTV, they give you the coordinates, and they want the perimeter. Well, like we said before, squares have consecutive sides that are congruent. So once again, you want to use the distance formula, and you could just do it on one side because the perimeter of a square is going to be the side of the square multiplied by 4. Okay, so when I did RS, right, we did -3 minus -1 plus, squared plus the y value is 1 minus 5 squared, right? And we end up with the square root of 20, and that's the length of one side of the square. But don't forget to multiply that by 4, and you get choice 3, which is 4 radical 20. And that will get you the perimeter using the information from way number 28. Now I'm still not done because on that same test, now they had a short answer question. This was a 2-point short answer question. Now they're telling you you have a rhombus again, PQRS, and they tell you the diagonals PR and QS intersect at point T. Okay, and remember they're perpendicular bisectors. All right, PR, which is this one, is 16, QS is 30, and again they want perimeter. Well, we need the length of one side. Now, you can't what you can do is use this information here. If this is 16, well, then this side is going to be 8, and this side is going to be 8. And if QS is 30, then that's 15, and that's 15. And basically, because you have 4 congruent right triangles, you could use the Pythagorean theorem now, because you know 8 and 15, right? And a squared plus b squared is equal to c squared. So you're just going to do that work and show that work, right? Because correct work is shown. Here it is. And you get 17, which is the length of just one side of that rhombus. But then don't forget again to multiply the 17 by 4, getting you the 68. And as long as you get that right and show the work this way, you get 2 points. Okay, and that's again from way number 28. And I'm still not done with way number 28 because going back to June 2017, okay, there was a multiple choice question that once again was asking about a rhombus. Okay, so a parallelogram that can always be classified as a rhombus. Well, number one, the diagonals are perpendicular bisectors. Yes, that's correct. Okay, so choice 1, 2, and 4 are all good. The diagonals bisect the angles from which they are drawn. So what they're saying is that this angle and this angle are equal. These angles are equal, right? So that's true too. So 1 and 2 could be right. This does not have Roman numeral 2, so that's out. So we're down to 1 and 4, and so Roman numeral 3, the diagonals form 4 congruent isosceles right triangles, which we learned from the last question. It did. So the answer is going to be choice 4 for that reason. Okay, again, using the information from way number 28. Okay, now if you're finding what the information I'm providing you is to be valuable, this guy is going to help you pass the Geometry Common Core Regents. Let me know. What I need you to do is stop the video right now, take a screenshot or a picture, and share that picture on social media. Put it on Twitter, put it on Instagram, make it on Snapchat, and if you can, include the hashtag Geometry Video Tutor. And this way I'll look that up and I could see if you guys are getting any valuable insights from this video so far. Okay, and so you continue watching the video at this point, and we'll move on to the next concept, which is some trigonometry. When you're seeing like sines and cosines, that deals with way number 35 on how to pass the Geometry Common Core Regents. Now, once again, I'm providing you with an explanation, but I think it's better to show you the video for way number 35, and after the video, we'll come back and I'll show you how to individually answer both of these multiple choice questions. Way number 35 on how to pass the Geometry Common Core Regents. The one cofunction identity that you need to know that is always true is the sine of A is equal to the cosine of B, especially in right triangles where angles A and B are complementary, meaning they add up to 90 degrees. Another way to put it would be the sine of an angle is equal to the cosine of 90 minus that angle. So see if you could answer this short answer question from the June 2016 Geometry Common Core Regents. If you said that R is equal to 17 degrees and provided the correct explanation, you'd earn yourself an easy 2 points. And even if they try to trick you with funky looking numbers or switching the letters around on you, the cosine of A will still be equal to the sine of B. And just in case you want to have a better understanding of this from the SOHCAHTOA standpoint, the sine of an angle is equal to the cosine of 90 degrees minus that angle, making choice 3 the answer on the left, and both students' equations are correct, along with a correct explanation. And the fact that both of these questions came from the same Geometry Common Core Regents exam is a good sign that you'll be able to pass yours. All right, that was way number 35 on how to pass the Geometry Common Core Regents. And basically, since the sine of A is equal to the cosine of B for complementary angles, then the sine of A will also equal 5 over 13, making the correct answer choice 3. They told you cosine of B is equal to the sine of A. Okay, so that is pretty basic right there. Now on the August 2017 Regents, they had a similar question, a little bit more advanced because this time they threw in an x. Well, we know that the sine of A is equal to the cosine of B for complementary angles. So that means 40 minus x plus the 3x is going to be equal to 90. Okay, so you got to add up to 90. That's this part right there. And then we want to combine the like terms. So we have 40 plus 2x is equal to 90. That's the next sentence right here. And then we're going to solve for x. We've got to subtract 40 from both sides. So 2x is equal to 50. And then divide both sides by 2, making the x equal to 25, which is choice 4. Okay, so that's how you handle way number 35 questions. All right, and so far on the June 2017 and August 2017 Geometry Common Core Regents, I've shown you how to answer multiple choice and short answer questions just from 3 different concepts from the 40 ways. Okay, and that means those 3 videos collectively could have earned you anywhere from 10 to 12 points on each exam. That means you need 22 to 23 more points to pass with a 65, and we still have 37 more videos left to get through. 37 videos. Do you see the value in that? Okay, so I value your time, and so therefore you have a choice. You have 2 choices right now. Choice 1 is you could go into the exam with what I've shown you today in the hopes that you pass, or you can watch the entire 40 Ways to Pass the Geometry Common Core Regents video series and get a guaranteed 65 plus. Okay, but before I tell you more about 40 Ways to Pass the Geometry Common Core Regents, I want to tell you what it's not. You're not going to be sitting in some lecture hall or classroom for 7 hours in a day. And you're definitely not going to be paying a very expensive fee for a course that's not even refundable if you fail. With 40 Ways to Pass the Geometry Common Core Regents, you could get through the entire course in just 70 minutes. That's like an hour and 10 minutes to learn a year's worth of material and then pass the Geometry Common Core Regents. Unbelievable. Guaranteed 65 plus, and for a fraction of the course, the cost of a crash course. All right, for a one-time fee of $69, you could get through the whole course in 70 minutes. You have access for 330 days. That means if you get it now, you could probably get through 3 Regents exams if necessary. Okay, but here's the best part. If it comes with a 100% money-back guarantee. All right, a tutor is not going to give the money back if you fail. A crash course is not going to give your money back if you fail, but I will. That's how confident I am, and hopefully you'll have knowledge and confidence to pass as well after watching this video series. Okay, and here's the explanation of the money back guarantee. Just watch the whole video series in its entirety, because if you end up failing the exam, send me an email with your failing grade and your certificate of completion, which you get when you finish watching the 100% of the video series, and I will gladly refund 100% of the purchase price. Just make sure to do that within 30 days of the exam. Okay, it's my personal guarantee to you. All right, and so what you need to do right now is just go underneath this video, click the Buy It Now button. If for some reason you're not on this page, you want to go to geometryvideotutor.com/40 ways, click the Buy It Now button, and you'll get set up. You'll be in the dashboard and you can start watching right away. Okay, and for sticking it out for a limited time only, I'm going to throw in a couple of bonuses here. Bonus number 1, a $10 value I'm going to give it to you for free, is the cheat sheet for 40 ways to pass the Geometry Common Core Regents. That's basically, I went through every concept of the 40 ways, right? And I give the explanation kind of like you saw in some of the videos, but here I'm giving you all 40 into like a 4-page PDF. I sell that for $10. You get it for free when you buy it now, but it's for a limited time only. I'm also going to throw in a second bonus. This is a $15 value. You're going to get it for free, and that was the How to Pass the August 2017 Geometry Common Core Regents. All right, and basically, like I showed you before, I show you which ways correspond to each question. All right, there out of 36 questions, 28 were covered. You got 58 points, which could have translated into an 80. I'll show you how every way with the explanation and the right answer. All right, and that's a $15 value, yours free, but for a limited time only. It may be available when you're watching this, it may not be. All right, that's up to you. All right, and all you need to do to secure that. All right, here's just an example, by the way, of what you get. Right, you have the way number, the concept, the explanation, the question, and the explanation further explained of how to get the right answer. Okay, so yours, depending on when you watch this video. And as a third bonus, a $15 value for free is How to Pass the Geometry Common Core Regents January 2018 edition. Again, this time there were 30 questions covered, totaling 70 points, which could have earned you a 91. Imagine if you got a 91 on the Geometry Common Core Regents. That'll be awesome. So that's also for limited time only, $15 value for free, depending on when you watch this. So all you need to do right now is click the Buy It Now button below this video, and I hope to see you on the other side. But either way, regardless of whatever decision you decide to make, I wish you the best of luck on the Geometry Common Core Regents, and send me an email. Let me know how you do. I'd love to get your feedback, and that is going to be the conclusion of this video. And so take care and have a great day.